Alrighty, here's part 2. Okay. Now we've let this sink in a little bit, and you're like, man, why didn't you show me this method before? Because you wouldn't have appreciated substitution if I'd have shown you this first. And I want you to have as many possible tools for solving a system as possible. Okay. So on this one, and I take a first glance at this, and I have coefficients of 9 and 3. And here I have -6 and 3. And so ideally, I look at this and I'm thinking, I don't feel like graphing this thing. And I really don't feel like substituting to try to get one of these variables by itself. So let's resort to elimination. First, make sure everything's lined up. That means standard form. X term, then the Y term, then the equal sign, and then your constant. And I've got that in both of these. Cool. Next, so we got that done. Now, we need to check and see if we can create opposites or if opposites already exist in either the X terms or the Y terms, so that when we add these together, whoosh, something drops out. So I'm looking at 9 and -6, and even though I have a positive and a negative, no, I don't have opposite numbers. I could get opposite numbers, but I'm looking here at the Y's. Both of these right now are at +3, and there's something that I can do really quickly to make this work. I need one of them to be a +3 and one of them to be -3, so that when I add them together, my Y terms completely disappear. So here's what I'm going to recommend we do. And really, it doesn't matter which one. You can do either one. But what I'm going to do is multiply the second equation on both sides by -1. And it's perfectly legal for me to do that because I'm doing the same thing to each side. Okay, so now what I'm going to do is rewrite my system this way. My top equation, I'm going to leave untouched. Okay, so I'm going to have 9x, a +3y, and -78. And then this equation, I'm going to multiply everything by -1. Distribute. +6x. Good, because I can't stand negatives. -3y or -3y. And then on this side, I get -57. All right. Now that I've manipulated or kind of changed the look of that second equation, let's add this equation to this one. And so you're adding equal things on each side. 15x, that goes away, 0y. So I'm just going to leave it as 15x. And then on this side, 135, -135. Now I'm going to divide both sides by 15. Don't lose your negative sign. And I get x has a value of -9. Does that look right? 90 and 45. Yes. X is -9. Okay. If x is -9, let's come over here and figure out what y is. Which equation do you want to use? Doesn't really matter. I'm going to use, I'll use the second one just because when I multiply -6 by -9, it'll turn positive. Okay, so -6 times x, I just said x was -9, plus 3y equals 57. That was my original equation. This gives me +54. Oh my word, look what's going to happen. Solve for y. You're going to subtract 54 and subtract 54. That goes away. Oh goodness sakes. 3y equals 3. So when you divide, that tells me y equals +1. Seriously? Seriously? Let's check. Check and make sure. Okay? I'm saying my final answer is -9, +1. So let's see if that's really the truth. Okay? 9x plus 3y equals -78. So let's plug that in. 9x plus 3y, oops, and y is 1, equals, let's see what happens. I'm supposed to get negative 78. This gives me negative 81 plus 3. Yes! Don't trust that it worked in one, so therefore it's a complete gimme. Go back and also check the original second equation, negative 6x plus 3y. So here's my other check. So that was check number 1. Here's check number 2. Now I forgot the equation already. Negative 6x plus 3y plus 3y. And I said y was 1. All right, these two give me a positive 54. This gives me a positive 3. I should get positive 57. Yes! Yes! Do your happy algebra dance. Everything checked. There you go. So in this case, I didn't have everything automatically set up with opposites. We had to do some manipulation to create opposites there. That's why I said multiply is the second step if you need to create opposites. All right, now let's try some on the next level. All right, so here's your next system. 4x minus 3y equals negative 1. 2x minus 2y equals negative 4. Okay. Everything's lined up. My x's, my y's, the equal sign, my constants. Okay, so everything's in standard form. So your job now, if we want to solve by elimination, is I want you to make opposites or find opposites either in the x terms or the y terms. So when I add these equations together, one of your variables is eliminated. So look at the x's. This is positive 4. This is positive 2. Yeah. I need one of them to be positive and one of them to be negative, and I need them to have the same value. So you've got some options here. Let's see. I could take the top equation and multiply it by negative 1/2, and then that would make this a negative 2, and then it would wipe out with the positive 2. Although then I'm doing halvesies, and these guys would be fractions. I could take this equation, the second one, and if I multiplied everything on both sides by negative 2, then x would become negative 4, and these guys would wipe out. Okay, so that's another option. If you focus in on your y values, okay, you could also attack here. If I try to get rid of the y's, I would probably find the first common multiple and then go from there. 3 and 2, the first common multiple would be 6. So I'd have to multiply this equation by 2 and this equation by 3. And then, oops, they're both negative. So then I'd have to multiply one of them by a negative value to make it positive. You could do that. Sounds like a few extra steps. I'm going to focus in on this equation. What I'm going to do is multiply this equation by negative 2, because then in one step, I'm going to create an x coefficient of negative 4, and then I can add them together and wipe out. All right. So first equation, again, for me is going to stay the same. So I'm going to write it again. 4x minus 3y equals negative 1. Then I'm going to take the second equation and I'm going to multiply both sides by negative 2. This gives me negative 4x, yes, plus 4y equals positive 8. Zip. All right, let's add these together and watch how everything falls out. Your x's are going to completely wipe each other out. Okay, they're like terms. A 4x and a negative 4x, 0x. Negative 3y and a positive 4y is a positive 1y. Oh my word, look at this. And negative 1 and 8 is 7. I'm done already with the y value. Oh my stars. Y is 7. Okay, so now let's use this information to figure out what x is. You can choose either equation. Frankly, you should choose both equations and make sure it works. Okay, that you get the same value for x. So in the first equation, I have 4 times x minus 3 times y, but I just said y is 7, and that equals negative 1. Okay, 4 times x minus 21 equals negative 1. Wipe out. That's 0. Oh my stars, look at how beautiful this works out. Not that we planned it this way. Yes, we did. X is 5. Okay, now let's make sure, just make sure, check, 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 check. Have I said that enough? Check, 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 check. 5 for x, because I'm saying my answer is 5, 7. Go to that first equation. 4 times x, 5, minus 3 times y. That better equal negative 1, because that's what it says. 20 minus 21, negative 1. Yes, that one worked. Let's check it in the original second equation. 5, 7. 2x, 2 times 5, minus 2 times y. Okay, in my equation up there, I better get negative 4. 10 minus 14. Boom, negative 4. Worked in this one as well. So your final answer is 5, 7. Sweet, 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 sweet. All right, let's get one that's kind of nasty. This is the last example. All right, so jot this one down, or if I have pre-printed notes that I've made in advance for you, then you've got this last example here. Okay. X terms are lined up. Y terms are lined up. Equal sign constant. Okay. Now, you get to decide what you want to attack. Do you want to get rid of the X's? Do you want to get rid of the Y's? It doesn't matter. It's all going to work out the same. As long as you keep doing legal moves, it'll work. So I have a negative 2 and a positive 3. I'm going to have to multiply both equations by something to create opposites. Okay. Same thing if I were choosing the y's. Both of these are positive. So first thing, I pick one of them to multiply by a negative. And then it looks like I have to get a common denominator, like a common multiple here, which is going to be 6, and go from there. So you have to decide, do I want to get rid of the x's or do I want to get rid of the y's? Here's my suggestion. Since the x's already have built in, one of them's negative, one of them's positive, I'm going to go with them. You totally could do the same thing over here. You just have to multiply by something to get one of these y's to be negative. That's all. I'm going to stick with x though. Okay, so you have a negative 2 and a positive 3. 2 and 3, 2 and 3. Common multiple, 2 and 3, 2 and 3. That means 6. So I want to multiply by something so that this coefficient of x becomes negative 6, and multiply this equation by something so that this coefficient becomes positive 6. Ta-da-ta-da. So here we go. I'm going to multiply the top equation by a positive 3. Do that on both sides. Okay, that's legal. This is going to give me a negative 6x. In fact, let's come down here and rewrite that first equation. Negative 6x plus 9y. All right, negative 15 times 3. Don't you dare grab a calculator. Who needs a stinking calculator? No. All right, next. I want this coefficient now to be positive 6, because then when I add these together, wipe out. So this equation, I am going to multiply both sides by 2, and I get a positive 6x. Yes. Plus 4y equals negative 46. Now we're going to add them all up. Wipe out for these guys, okay? All gone. 13y. Ooh. Don't worry. I made it nice. Negative 45 and negative 46 is negative 80 and negative 11 more, so negative 91. All right. Fear not, sports fans, because 13 can fit exactly into or is a factor of 91. Yes. In fact, this gives me negative 7. What is this madness? Works out. Let's pick an equation and let's figure out what x is. Now I got a lot to write here, so I think I'm just going to come over here. Negative 2 times x, I don't know x yet, plus 3y, plus 3 times y, which I just said is this, equals negative 15. Okay, now are you kind of understanding why we made you work and get all of this positive and negative integers and get those facts down pretty quickly? Ooh, minus 21. I hate writing that extra plus sign. Minus 21 equals negative 15. All right, add 21 to each side, and you get negative 2x. That wipes out. Is 6. Don't go too fast and make a little error with a negative sign. That's what I always do. All right, it looks to me like x should equal negative 3. Psst, this is why you check them in both equations, because it is so easy to just start zooming along and dropping a sign or making one of those little errors in computation. So we want to make sure we get that correct. Negative 3, negative 7. In the first equation, negative 2x plus 3y. Negative 2x plus 3y. Plug in negative 3 for x, negative 7 for y. 6. This becomes negative 21. I get negative 15. Was that my first equation? Yes! First equation checks. Let's check the other one. 3x plus 2y. 3x plus 2y. Plug a negative 3 in for x. Plug a negative 7 for y. What did I put y there for? Oh, get that out of there. We're substituting now and checking it. Plug a negative 7 in for y. Okay, I get this is negative 9. This is negative 14. When you add those together, I get negative 23. Moment of truth. Oh! Woo! Whoa! That was awesome. Awesome. This is solving systems by elimination. Wowza. What an absolutely great method to use. Don't hate me because I was making you graph and use substitution first, okay? It built character. It also gave you other tools in your resources and how to take and tackle these in a variety of ways, okay? Now you can move on to your assignment. Check on Schoology and see what it is. And as always, may the force be with you.